Hey everyone, welcome to another video on ratios. Now, today we're going to be talking about simplifying ratios, which actually kind of goes quite hand in hand with what we learned in the previous video when we talked about equivalent ratios towards the end. Now, this first question is going to be a little bit of a revision into that, and we're going to look at this first question and then we're going to look at some similar, kind of trickier questions to navigate. But only thing we're talking about today is this idea of simplifying our ratios. Now, I have here the ratio of 15 to 25. And in the previous video, we looked at finding equivalent ratios. And this was the process of simplifying what we now know as simplifying. So if you remember from the last video, we just looked at, well, to simplify this, to make it to the lowest possible ratio, we want to look at the highest common factor. So the highest number that goes into, or the highest number that goes into both 15 and 25. Now, if you know your times tables, then you should be able to see that 5 goes into both of these numbers. And we want to get these numbers smaller to the smallest possible ratio. So we're going to divide both by 5. So dividing 15 by 5 gives me 3. And I'm still going to put my ratio symbol here. Dividing 25 by 5 gives me 5 here. So I have reduced this ratio into a simpler type of ratio, which tells me the same idea, right? Saying that for every 3 things, another thing has 5. That is the same as saying, well, then for 15 of this first thing, I'm going to have 25 of the other. It's the same as that cordial jug analogy we talked about in the previous video. Now, let's move in a further direction here. So we want to we've looked at simplifying whole number ratios. Let's look at what happens when we want to simplify fractions, for example. So let's look at example 1 here. I want to simplify, let's say, 1/2 to 1/3. So what I'm doing here is I'm saying that for each half I have of something, I need to put a third of another thing. So how can we even approach this? Well, actually, let's try an even simpler example, then we'll go to this one next. Let's look at a 1/2 to 1. So we're saying that for every half of one thing, I have 1 of another thing. You can think of this as any type of analogy. You can even think of the cordial one, right? For each half of a glass of cordial, I'm going to put a glass of water. If I wanted to make this this cordial have a bit of a stronger taste, right? So what am I going to do here? Well, I'm going to first just write out my ratio again down here. 1/2 to 1. So for each half here, I have 1 here. So when we talk about ratios, we don't like dealing with fractions. We like to get ratios to the smallest possible whole numbers. Now, for each half, there is 1. So what is the smallest whole number I can get a half to? Well, I can get it to 1, the smallest whole number that we know. Now, how can I get a 1/2 to 1? Well, I can take 2 lots of a half. I can take 2 lots of a half to get this to 1. And what I do to one side of the ratio, I want to do to the other. So taking 2 halves gives me 1, and taking 2 lots of 1 gives me 2. This is an equivalent ratio with the smallest possible whole numbers we can get. So in the same way that we can simplify these bigger ratios to smaller ones, we can also simplify these smaller ratios, these fractions, to bigger numbers or to just whole numbers in general. And this should hopefully make sense because for each half of one thing, I have one of another thing. Then therefore, they should, well, sorry, let me rephrase that. My number here should always be 2 lots of this number. So let's write that here. This number is always 2 lots of my other number. And what we get to here progresses in the same way. I get, when I find half as a whole number, when I want to express this as a whole number for my ratio, making this 1, we would expect the number here, once we do this step of simplifying, to be 2 lots of my number on the left, which we can see once again, it's happening. Now, let's move to the example we talked about previously. So this idea of 1/2, simplifying 1/2 to 1/3. Now, what do I want to do here? Well, I want to make both of these whole numbers, right? And I want to multiply both of these by a number that is going to produce a whole number in both. Now, how can I do that? Well, for this particular ratio, I want to get both of these to a whole number, and I can do that by considering what the highest common factor of these particular things here. Oh, sorry. I've got my concepts confused. I want the lowest common denominator. Sorry. Because by finding the lowest common denominator with these two highlighted denominators, when I multiply both of these fractions by the lowest common denominator, I'm going to get a nice whole number. So what's the lowest number that both 2 and 3 go into? Well, that number is going to be 6. So I'm going to times both left and right by 6, and that's going to give me my ratio in a much nicer form. So if I take 6 halves, or 6 lots of a half, I'm going to get 3. And if I take 6 lots of a third, I'm going to get 2. And it makes sense that the 3 here is bigger than the 2 because a fraction of a half is bigger than a fraction of a third. This is a way we can kind of sense check the answer we get to make sure it makes sense. But the most important thing to note here is that my ratio on the top with fractions and my ratio on the bottom with whole numbers, these are telling us the same information. These are equivalent ratios. But when we use ratios, the tradition for when we use these, and an easier way to look at them, is to get them in terms of whole numbers. But we can do this for fractions by first considering the lowest common denominator of both fractions. And then we just multiply each by the lowest common denominator because we know that's going to guarantee that we get some nice whole numbers to finish off our ratio. This answer we got down the bottom of 3 to 2. All right. Let's look at one more concept here, and it all ties into the idea of simplifying ratios. But now I want to look at simplifying ratios when units are involved. So simplifying ratios when units are involved. Now, this has a lot of carryover to imagine things like cooking, right? When you've got different ingredients and you've got different sizes of those ingredients. Sometimes if you have a really small amount of one thing relative to a big amount of another thing, we often use different units. And we can come up with ratios by first converting the quantities, the measured thing, to the same unit. Now, let's look at that for a second. So, example 3, I want to simplify 4 millimeters to 2 centimeters. Now, what I'm going to do here, I'm going to deliberately make a mistake, and we're going to kind of sense check our way out of this. So, sometimes students could look at this and go, all right, a 4 and a 2. So my ratio means that, okay, well, for each 4 here, I have 2 here. And then let me simplify this because I know 2 goes into both of these. So I'm going to divide by 2 and I get left with, this is all things we've been doing in the previous videos. That's why I'm going through it a little faster. But this thing tells me, this mistake that I've made, well, this says that for each centimeter, I have 2 millimeters, which a millimeter is a smaller unit than a centimeter. So that doesn't really make sense. This violates what we know about measurement. I'm taking a smaller unit, because millimeters are a smaller unit of measurement, and I'm saying through this ratio that that's larger than the unit of 2 centimeters. That doesn't work. So this is why we need to convert this first for it to make sense. So we want to bring these all to the same unit, because my millimeters and centimeters here, they're kind of speaking a different language. I want these to be communicating in a similar language. So I'm going to choose the language of millimeters here. So I'm going to say I want to convert units to millimeters. Okay, well, my 4 millimeters is going to stay as 4. And 2 centimeters, well, how many millimeters are in a centimeter? Well, there are 10 millimeters in a centimeter. So in 2 centimeters, I have 20 millimeters. And now I can say, all right, well, what number goes into both 4 and 20? Well, 4 goes into both of these. So I'm going to divide both sides of my ratio by 4. And I get left with 1 here. And I get left with 5 here. So this ratio, if we look at it through the question, in the kind of context of this question, this kind of makes a little bit more sense, because it makes sense for there to be more centimeter units for a millimeter unit in an example where this number ends up being bigger than this one. So If you look at, for example, if some of you guys have a 30 centimeter ruler and it's got the little millimeter markings, you'll be able to count 5 of these 4 millimeter notches for every 2 centimeters. So that means that what my ratio is telling me is that for each measurement here of 4, I can find 5 of those in my 2 centimeter measurement. And the great thing about these questions is it doesn't matter whether I converted to millimeters first or centimeters first, I'm going to get to the same answer. Let me show you. What if I instead decided to convert the units to centimeters? Well, the 2 centimeters would stay. And I would say, well, how can I write 4 millimeters as centimeters? So I would write that as 0.4. Now, I can also write 0.4. This is a revision of fractions, decimals, percentages. You can see how there's a carryover here. I can write this as 4/10, or 4 divided by 10, to 2. Now what I want to do is I want to kill this denominator here. I want to leave this thing in terms of whole numbers. So what I'm going to do is to both of these numbers in my ratio, I'm going to multiply them by 10 because that's going to kill off this denominator, give me a whole number. And what I do to one part of the ratio, I want to do to the other. Now, timesing both of these by 10, I get 4 to 20, which is the same thing I had here when I converted to millimeters. I get the exact same thing. And then from here, we can simplify again. We can say that I can divide both of these by 4, divide by 4, and I'm left with a ratio of 1 to 5. But that is how we can go about working with ratios and simplifying them when different units are involved. And now, just for the end of the video, I'm going to leave a couple of questions just for you guys to practice. It's a new thing we're going to try to do here, but I want you to simplify, if you want to, for extra practice, simplify the following ratios. The following ratios. So question 1 is simplifying 7 to 21. Question 2 is simplifying 3/5 to 1/2. And the third question, we're going to use a unit question. We want to express 25 minutes to 2 hours as a ratio. So for this last one, once again, don't be fooled. We want to be speaking the same language. We need these two in the same unit for us to simplify the ratio. But that's it for this video. This will hopefully give you a nice, long, comprehensive look at how we can go about simplifying ratios, both for whole numbers, for fractions, and for quantities with different units. And for this last bit especially, there's a lot of carryover in the real world, thinking about cooking or ratios of measurements or even scale drawings on maps, which we'll look at in the future too. But thank you so much for joining me today. I'll see you in the next one.